we have a question that there is an ideal spring of spring constant K. Now listen, here the question is, an ideal spring with spring constant K is hung from the ceiling and a block of mass M is attached to its lower end. Listen, first the block of mass M is attached to the spring with the lower end. At that time, the spring was at its normal position, right? When it is being stretched, it will fall down. Again, with the maximum stretch, it will be at rest, right? In any spring, suppose it is ideal, then with spring constant K, when it is being stretched, energy is stored in the spring, right? That energy will reduce when the body gains kinetic energy. Alright? Now listen. Suppose the body is coming down with the stretching of the spring, it will attain a distance. So there will be increment in the spring. That length we can say as x. So let x is the distance by which spring stretch, right? Spring stretched. Now listen, if the block was at its normal position when the spring has not stretched, there is no elongation in the spring. But when the body comes down, there is elongation in the spring. Alright? Now, what elongation is taking place in the spring, that amount we let as x. Now, the potential energy stored in spring due to elongation is mg x, and again it is equal to half kx square, as energy can neither be created nor be destroyed. Understood? Here is a block which was at position A when the spring was not stretched, but when we relax it, it will come down due to gravitational force. At that time, spring will stretch. So the amount by which spring is stretched will let at x. Alright, now solve it. Mg equal to 1 by 2 kx. Alright, so 2 mg upon k equal to, so what elongation takes place in the spring? 2 mg by, understood? So listen, whenever you have to find that what elongation is taking place in a spring, just use work energy theorem. That the energy can neither be created nor be destroyed. The energy which has been stored in spring is again changed into kinetic energy. Alright? So whatever potential energy has present on the spring, it will change in kx square. Right? So the potential energy due to height is mgx, and it is being changed in half kx square. So as energy can neither be created nor be destroyed, there will be no loss. Right? So we have assumed that there is no loss of energy, so directly we can write equation mgx equal to half kx square. Now x cancel. Alright, so 2 mg by k is equal to x. So this x is elongation in spring due to that block which is coming down. Suppose the spring was at normal position, the block comes down, then the spring elongates. So how much distance, by how much distance the spring elongates, that is x. Alright.